What's going on, everybody? Today, I want to talk about three stories that, on the surface, have almost nothing to do with each other. We've got Boeing, we've got a live shopping startup called Whatnot, and we've got Ford essentially trying to reinvent how it builds automobiles. Aerospace, e commerce, automotive manufacturing. So, three completely different industries, but from where I'm sitting as a software engineer, tech founder, and entrepreneur, all three stories are actually talking about the same thing. Technology is moving faster. Old business models are under attack. Distribution is becoming insanely valuable. And the companies that cannot continuously reinvent their systems eventually pay for it. That's what I want to unpack today because I don't want to read headlines. I'm interested in what these things mean if you're building something. What can founders learn? What can software engineers learn? And what can entrepreneurs learn? And most importantly, where are the opportunities being created? Because disruption destroys old assumptions, but disruption also creates companies. Now, let's get into it. So, the first story we have up on the list is the Boeing and the cost of engineering trust. Now, the FAA has ordered inspections covering 471 Boeing 700 or 737 MAX aircraft over concerns involving possible cracking around structural components near the forward doors. And there's an important distinction here. This doesn't mean regulators suddenly discovered cracks across hundreds of MAX aircraft. The concern comes from cracking previously identified in older 737 next generation aircraft because similar manufacturing and design methods exist in the MAX family, and the regulators want those aircraft inspected as well. Now, that might sound like a small distinction, but it isn't because this is a perfect example of something engineers understand extremely well. You investigate failure patterns before they become catastrophic failures. That's good engineering. You don't wait for production to completely collapse. You look for the signal. You identify the failure mode, you inspect adjacent systems, and you determine whether the problem propagates, and then you remediate it. That's literally what we do in software. If I discover a vulnerability inside one authentication service, I'm not just patching that particular instance. I'm asking, what else did we use, or where else did we use this architecture? What other applications inherited this dependency? Was this implementation copied? Can this failure propagate? That's systems thinking. And aerospace might be one of the purest examples of why systems thinking matters. But there's another layer here. Now, just a few weeks ago, the FAA announced that Boeing could resume issuing airworthiness certificates for all new 737 MAX and 787 airplanes after months of oversight and production quality reviews. That's significant because Boeing lost that authority for the MAX following the two crashes in 2018 and 2019. So think about the business situation. Boeing isn't simply manufacturing airplanes, they're rebuilding institutional trust, and that's much harder. You can repair a component, you can rewrite software, you can change the manufacturing process, but once customers, regulators, employees, investors, or the public begin questioning whether the underlying system works, now you're rebuilding confidence in the entire machine. Now, moving on. Well, before we move on, I guess the founder lesson from Boeing is technical debt eventually becomes business debt. So, early stage founders love saying, we'll fix that later. Sometimes that's completely reasonable. You're building an MVP, you're validating demand. You don't need NASA grade architecture for 13 users. But eventually, we'll fix it later has to become we fixed it. Because when your system begins handling money, healthcare, transportation, infrastructure, autonomous systems, enterprise data, or even human safety, the engineering standards change. And this is especially relevant as AI starts writing more software. AI is going to dramatically accelerate software development. I strongly believe that's a good thing. I've already watched AI allow engineers to prototype systems in days that previously might have taken weeks. But faster development cannot mean abandoning engineering discipline. In fact, AI makes architecture testing, observability, security, code review, and the validation more important, not less important, because now we can produce mistakes at machine speed too. That's the trade off. AI gives you leverage, engineering gives you that or gives that leverage discipline. Now, some questions I have for the chat. Would you personally hesitate to fly on a Boeing 737 MAX today? Yes or no? And I'm not asking whether the statistics say you should. I'm asking about perception because perception is part of the business problem. Now, before we continue, give me just one sec. All right, let's continue. So, moving on to story number two, we have Whatnot. Now we're going to completely change industries here. So Whatnot launched in 2019. Initially, it was heavily associated with collectibles, trading cards, comics, things like that. Today, Whatnot has raised another $545 million at a valuation of approximately $20 million. I'm sorry, $20 billion. And there's something founders need to study here because Whatnot didn't invent e commerce. They didn't invent auctions. They didn't invent live streaming. And they didn't invent collectibles. They combined existing behaviors into a different experience. That's innovation too. Sometimes founders convince themselves that innovation means inventing technology nobody has ever seen before. Wrong. Some of the biggest companies in the world took existing technologies and changed the interface, distribution mechanism, economics, or experience around them. Whatnot understood something important. Shopping can also be entertainment. Think about traditional e commerce. Search, click, scroll, product page, add to cart, checkout. Efficient? Absolutely. Exciting? Not necessarily. Whatnot adds a human being, personality, urgency, competition, live interaction, discovery. Now you're not simply buying a collectible, you're watching a show. That's a completely different product psychology. And according to reporting around this latest round, Whatnot's gross merchandise volume exceeded $8 billion during the first half of 2026 alone. And that's insane scale. And this is something I'm becoming increasingly convinced of as a founder. Building the product is no longer enough. You need the distribution. I've spent years thinking heavily about engineering, architecture, applications, cloud, AI, infrastructure. All of that matters, but I've become increasingly obsessed with the question, how does the thing spread? Because you can build incredible software that nobody knows exists. Meanwhile, somebody else can build something technologically simpler with incredible distribution and create a $1 billion company. That's not necessarily unfair. Distribution is a skill, and Whatnot demonstrates it beautifully. They didn't eliminate sellers, they turned sellers into broadcasters. The sellers become part merchant, influencer, entertainer, community manager, salesperson. The platform then benefits from thousands of independent personalities creating content and demand. And that's powerful. Now imagine where live commerce goes with AI. Real-time translation, AI sales assistance, automated product descriptions, dynamic pricing, instant clipping of live stream highlights, AI-generated advertising, fraud detection, personalized recommendations, automatic customer support, seller analytics, and potentially AI generated hosts. We're going to see commerce become dramatically more personalized. And some of this could get weird because eventually the best salesperson you encounter online might not actually be a person. That's where ethical questions start becoming serious. How persuasive should AI systems be allowed to become? When does personalization become manipulation? When does engagement optimization becomes addiction optimization? And those aren't science fiction questions anymore. They're product design questions. Now, some questions I have for the chat. Would you buy something from an AI live stream host if you knew it wasn't human? Drop a yes or no, because I think eventually millions of people absolutely will. Now, here's my takeaway from Whatnot. Don't ask only what technology you can build. Ask what behavior you can amplify. People already love collectibles. People already love live streams, and people already follow personalities. People already bought things online. Whatnot put those behaviors together. Now that is an important mental model for founders. Instead of saying what completely original idea can I invent, ask what are people already doing badly, inefficiently, or across 5 different platforms that I can combine into one better experience. That's where some massive businesses come from. Now, this might actually be my favorite story because Ford isn't simply launching another electric vehicle, they're attacking the underlying manufacturing architecture. And that interests me. Ford previously made an enormous bet on EVs. Part of that strategy didn't work. In December 2025, Ford announced a restructuring of its EV business, carrying approximately $19.5 billion in special charges. Ford also ended production of the current fully electric generation of the F-150 Lightning. Think about that number, $19.5 billion. Companies at this scale can make mistakes that will erase entire startup ecosystems. But here's the important part. Ford didn't say EVs didn't work, we're done. They changed the architecture. Ford has been developing what it calls its universal electric vehicle platform. And they're pairing that with a completely different manufacturing concept. Ford has described the approach as moving away from the traditional sequential assembly line toward more of an assembly tree. That's fascinating. Instead of everything progressing through one massive sequential process, major vehicle sections can be assembled in parallel before being brought together. Software engineers should immediately recognize the philosophy. Parallelization, modularity, reusable architecture, platform engineering, standardization, reducing dependencies. That's basically software architecture being applied to physical manufacturing. And the first big product is the Fathom, Ford's newly announced electric pickup. The Fathom is expected to start at approximately $28,350. Now think about what Ford is targeting. Not the $80,000 luxury EV buyer, not somebody buying a vehicle as a technological status symbol. They're trying to go back after a huge portion of the mass market. That's a fundamentally different strategy because the average new vehicle has become extremely expensive. And when vehicles regularly cross $50,000, something weird happens. People start stretching loans. 6 years, 7 years, even 8 years. At some point, your product stops serving the middle class, and that creates a giant opening underneath you. Now, this is classic disruption. Big companies move upscale, margins improve, our products become more sophisticated, customers ask for more features, so companies add bigger screens, more software, more luxury, more technology, more expensive materials. China has already demonstrated an incredible capacity for manufacturing lower cost EVs internationally. You've also got companies like Slate attempting to attack the affordable American pickup category. So Ford has a choice: protect the premium market forever or attack its own assumptions. And Ford appears to be choosing the second option. Now, Ford's smartest move here may not actually be the Fathom, it might be the platform underneath it. because platforms compound. If Ford creates a manufacturing and vehicle architecture that supports a pickup, a van, an SUV, a compact vehicle, and potentially additional models, now you're not building individual products from scratch. You're building a system capable of producing products. That distinction is huge, and it's exactly how I think about software. You shouldn't build 15 completely unrelated applications from zero. Build infrastructure, authentication, payments, analytics, AI orchestration, deployment pipelines, observability, reusable components, data infrastructure. Then every new application benefits from everything you've already learned. That's compounding engineering. Now we're entering an era where companies can iterate much faster because AI compresses engineering time. Software development, industrial design, simulation, digital twin, supply chain optimization, robotics, computer vision, autonomous systems, predictive maintenance, factory planning. AI is going to touch almost all of it, and this is why I'm extremely bullish on the future of software engineering. I don't think AI means software engineering disappears. I think it means the amount of software humanity can create explodes. One good engineer with powerful AI tooling can begin operating more like an engineering team. A small startup can begin competing with organizations that used to require dozens of people, but there's another side. Greater leverage creates greater consequences, and AI eventually controls infrastructure, transportation, weapons, financial systems, factories, communication, energy. Then bad engineering, malicious actors, and poorly aligned autonomous systems can do exponentially more damage too. So I'm optimistic, but I'm not naive. The same technology that allows a two-person startup to create something incredible could also give a malicious person capabilities that previously required an organization. That's why the next decade isn't only about capability, it's about capability plus control plus responsibility. Now, zoom out. Why did I put Boeing, Whatnot, and Ford in the same live stream? Because they're three versions of the same economic story. Boeing teaches us reliability compounds, and so does technical debt. Engineering quality eventually becomes a business issue. Whatnot teaches us distribution can be as valuable as the underlying technology. Don't simply build products, build systems that make people participate. Ford teaches us when the old architecture stops working, don't just optimize it, replace it. Sometimes the answer is in making the assembly line 5% faster. Sometimes you build an assembly tree. That is founder thinking. And I think we're entering one of the most interesting entrepreneurial periods we've ever seen because AI dramatically lowers the cost of experimentation. 20 years ago, if you wanted to create a technology company, you might need servers, employees, capital, office space, engineers, infrastructure, distribution agreements. Today, you can get an idea tonight, prototype it this weekend, deploy it globally, accept payments, generate marketing assets, translate it into multiple languages, analyze customer behavior, and have AI helping you with practically every step. That is historically abnormal. We're getting used to it because we're living through it, but this level of leverage is insane. Now, this is why I keep telling people stop waiting. You don't need permission anymore. If you're a developer watching this, build. If you're an entrepreneur, experiment. If you have industry expertise, start looking for inefficient workflows. If you're young, learn AI, learn software, learn sales, learn distribution. Learn how businesses actually make money because those skills are converging. The founder of the future isn't just a CEO sitting in meetings. They're increasingly going to be able to understand product, engineering, AI, distribution, capital, operations, and then use intelligent systems to amplify themselves across all five. That's the game I'm personally trying to play. I'm not interested in watching AI happen. I'm interested in building during it. So I'm going to leave you with three questions. Number one, would you trust AI generated software inside systems where human lives are at stake? Number two, is distribution becoming more important than technology itself? And number three, if AI suddenly made you 10 times more productive tomorrow, what would you actually build? Because that's the question that matters. Not is AI coming, it's already here. The question now is, what are you going to do with the leverage. I'm a software engineer, tech founder, and entrepreneur. I'm Eugene. I build products, work with companies on software and AI systems, and document what I'm learning along the way. If you're interested in AI, startups, software engineering, emerging technology, and actually building through this transition, subscribe. We're not watching the future from the sidelines, we're engineering our way into it. Execute, push, build.